This video covers report period 3, week 4 homework for Spelman and Morehouse. On Monday, we're working on writing expressions to represent situations involving addition and subtraction. The directions say to show your work to answer each question. Whoops, we're back. And be sure to answer every part of the question. Let's use question 1 as our model. Miss Burton has been teaching for 3 years longer than Miss Knez. Complete the table. There are many different ways you could complete this table because I didn't give you any guidance on what numbers have to go in the table. So, you simply want to pick a number for Miss Burton or Miss Knez to get you started. Let's say, for example, that we decide that Miss Knez has been teaching in this part of the table for 1 year. I know that Miss Burton has been teaching for 3 years longer than Miss Knez. I know that from this part of the question here. I know that 3 years longer than 1 is 4, because 1 add 3 equals 4. A simple way to go about the table is simply to count Miss Knez's years of experience by ones. But really, you could put anything you want. If Miss Knez has taught for 2 years and Miss Burton has taught for 3 years more, I know that Miss Knez has taught for 5 years. Miss Burton has taught for 5 years. If Miss Knez has taught for 3 years, again, Miss Burton has taught for 3 years more, so Miss Burton has taught for 6. I could also choose another number, besides counting by ones. For example, if Miss Knez has taught for 10 years, I know Miss Burton has taught for 3 more, so I'll add 3, for a total of 13 years for Miss Burton. Of course, what this table is really designed to help us do is answer question B, because that's our focus for this unit. Miss Knez's years of experience can be represented by K. K is a variable that represents a mystery number, but any possible numbers of experience for Miss Knez. Write an expression to represent Miss Burton's years of experience. In other words, what can I always do to K, Miss Knez's years of experience, to figure out or represent Miss Burton's years of experience? I can see the pattern clearly in the table, because no matter what K is, K being any possible years of experience Miss Knez has, I can always take K and add 3. Again, K just means any possible years of experience that Miss Knez has had. And no matter what number K would be, we would always add 3 to figure out Miss Burton's experience. Let's take a look at Tuesday's example. On Tuesday's homework, we're working with a similar type of question, except this time we're thinking about relationships involving multiplication and division instead of addition and subtraction. Let's read question 1. A radio station plays 12 songs each hour. They never stop for commercials, news, weather, or traffic reports. Write an expression describing how many songs are played by the radio station in H hours. Even though there's no table on this question, it can be helpful to draw one to help us if we get stuck. Because what a table does is it helps us to more clearly see the relationship that's being described in the problem. I know that in 1 hour, 12 songs are played. That means that in 2 hours, 24 songs are played. Because when I added another hour, another 12 songs got played. Now, if I jumped up in my table all the way to 10 hours, I might not want to skip count by 12 10 times. I can see the pattern across the table. 1 times 12 equals 12, 2 times 12 equals 24, and 10 times 12 equals 120. Question A is asking us to write an expression, that's an equation without an equal sign, using the variable h. H is any possible number of hours. So what the question is asking is, no matter what the hours are, what can I do to the hours to figure out the number of songs? I can see that pattern clearly in the table. I multiply the number of hours times 12. Of course, the middle school way to write hours times 12 is simply 12H. Question B asks us how many songs will be played in an entire day, which is 24 hours. Again, I know that no matter how many hours there are, I can multiply that times 12 to figure out how many songs are played. 24 times 12 tells me that in 24 hours, there are a total of 288 songs played. Make sure you have your label on your answer. Of course, we know that we can look at the table to see that pattern and skip count all the way down to 24 hours, but multiplying by 12 is a much quicker way. In question C, they ask us, how long does it take the radio station to play 60 consecutive songs? Let's think about the original relationship. I know that 12 multiplied by some number of hours is going to get me to 60 songs. Some of you may see this multiplication sentence and immediately know the answer, that H is equal to 5, and your final answer is 5 hours. If you didn't see that right away, you could always divide 60 divided by 12 for a total of 5 hours. Because dividing the product, 60, by the factor we know, 12, will always give us the missing factor. If we zoom in on the table, we are reminded that to move from hours to songs, we are multiplying by 12. But if I'm moving across the table in the opposite direction, I know the number of songs and I need to find the number of hours, I can use the inverse operation. 12 divided by 12 is 1, 24 divided by 12 is 2, and oops, I made a mistake back here. That was 120 divided by 12 is 10. So to get from S, songs, to H, hours, I use division. We know that division and multiplication undo each other. So when we look at these one-step tables, we can always move in the reverse direction using the inverse operation. Let's look at Wednesday. On Wednesday night's homework, you have a two-step problem. We'll use one as our example. Compact discs cost $12 each at the Music Emporium. The company charges $4.50 for shipping and handling, regardless of how many compact discs are purchased. I know that I am going to have to pay $12 for one CD. If I look at this one CD, it's going to cost me $12. But remember, in addition to the $12 that I pay for the one CD, 1 times 12, I also need to add on that shipping fee, which is $4.50. So I'm paying a total cost of $16.50. That's for one CD. I got $16.50 because I paid $12 for the CD and $4.50 for shipping. Let's think about what would happen if I were to purchase 2 CDs. To purchase 2 CDs, I need to multiply 2 times 12 because each of the CDs is going to cost $12. But I don't need to pay the shipping fee more than once because the directions say regardless of how many CDs are purchased, which means I can multiply 2 times 12 and simply add that flat shipping fee of $4.50. So I end up paying a total of $28.50 for 2 CDs. Notice that I am multiplying by 12, which is the cost for one CD, but I'm adding $4.50 because that's the cost to ship. And the cost to ship does not change depending on how many CDs I buy. You'll do row 3 in the exact same way. This is a good time to pause the video to complete row 3 on your own. We already did question A. Question A says, create a table of values that shows the relationship between the number of compact discs that Mikey buys and the amount of money Mikey spends, C, in dollars. Once you complete your table, you can check that off. B says, if you know how many CDs Mikey orders, can you determine how much money he spends? Write the corresponding expression. Let's zoom into our table. I can see that I am taking the number of CDs that Mikey buys, 1 or 2, and doing the same thing each time. Let's write it out here. I'm multiplying C, the number of CDs, times 12, the cost per CD. This C just means no matter how many CDs I buy, I need to multiply the cost by 12. After I multiply the cost of CDs by 12, I'm going to go ahead and I am going to add the shipping fee. Again, the reason why we add the shipping fee is because the shipping fee does not change depending on how many CDs you buy. It's going to be $4.50 no matter what. I can rewrite this expression in the middle school way, 12C plus $4.50. Question C says, use your expression to determine how much Mikey spent buying 8 CDs. I'm going to leave you to solve question C on your own. You have the expression, and you know that this C, the number of CDs, is equal to 8, which means we can rewrite the expression and solve. Finally, we have Thursday night's homework. On Thursday night's homework, it's not in this document. Thursday night's homework is a review of a topic that will be covered on the PSSA. On Thursday night's homework, you're just completing fluency activities. What I'll do, since I don't have the document linked here, is I'll upload a part 2 of this video with Thursday. I'll link it in the notes.